In this lesson, we'll be learning about tangent lines. The objective is to use properties of a tangent to a circle. So what is a tangent to a circle? A tangent to a circle we're going to use the symbol for a circle, which is a circle with a dot in the middle to represent the center of the circle. A tangent to a circle is a line in a plane of the circle that intersects the circle in exactly one point. Now, the point where the circle and the tangent line intersect is called the point of tangency. The first theorem in this lesson says that if a line is tangent to a circle, then the line is perpendicular to the radius of the circle at the point of tangency. So let's look at the diagram and see how that applies. Here we have line AB. So if line AB is tangent to circle O, and this is how we're going to name the circle, is you use the symbol for a circle, which is the circle with the dot in the middle, and then you name it with its center. So if line AB is tangent to circle O at point P, then line AB has to be perpendicular to line OP, because line OP is the line that contains the radius of the circle. The second theorem in the lesson is really the converse of that first one. It says if a line in a plane of a circle is perpendicular to a radius at its endpoint on the circle, then the line is tangent to the circle. So here in this diagram, it's already showing us line AB is perpendicular to segment OP, and OP is a radius of the circle. So if line AB is perpendicular to line OP at point P, which is the end point of the radius that's on the circle, then that means that line AB is tangent to circle O. The third theorem in this lesson says that if two tangent segments to a circle share a common endpoint outside of the circle, then those two segments are going to be congruent. So here in this diagram, we have a common point B outside the circle, and we have two tangent segments that are BA and BC. So if segment BA and BC are tangent to circle O, then that means that segment BA has to be congruent to segment BC. So we can mark that with congruent mark those as congruent segments. The last part of this is just some definitions for tangent. In the figure below, the sides of the triangle are tangent to the circle. And if they're tangent to the circle is inscribed in the triangle and the triangle is circumscribed about the circle. So that's just some definitions to put that into perspective. Let's look at the problems and apply these theorems. In the first problem, we're finding angle measures. It tells us that segment AD and segment AG are tangent to circle O. And I want you to find the value of x. So what does that tell you? The first theorem in this lesson says if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So that means that there's a right angle at point D, and there's a right angle over at point G, those 2 points of tangency. So we have a quadrilateral, and in a quadrilateral, the sum of the interior angles is 360. So if we add together the 90 plus the 90, those two right angles, plus the 152, plus the x that we need to find, those 4 angles, the sum of those interior angles has to be 360. So if we add together the 90, and the 152, subtract that from both sides, x is going to be 28 degrees. In problem 2, you're finding a distance. It says Jasmine is riding in an airplane at an altitude of about 6.5 miles above the Earth. How far on the Earth can she see if the Earth's radius is about 4,000 miles? Round it to the nearest mile. You really need to sketch this to get a picture of what this is asking for. So just draw a circle to represent the Earth in the center of the Earth, and then draw a radius. So this radius is 4,000 miles. Now we have Jasmine in a plane above the Earth. So let's see if I can draw a plane above the Earth. So she is 6.5 miles above the Earth. And we want to calculate this distance that she can see to the Earth. So that's the value that we need to find. So let's go ahead and complete this triangle, because this is also another radius of 4,000 that's forming the hypotenuse of that right triangle. So use the Pythagorean theorem. C squared equals a squared plus b squared, where c squared is always your hypotenuse. The hypotenuse is opposite the right angle. So the side of the triangle that's opposite the right angle is the 4,000 plus the 6.5. Then the legs of the right triangle, the x that we're trying to find, x squared. And then the other leg of the right triangle is the 4,000, which is the radius of the circle. So that's 4,000 squared. So if you add 4,000 plus 6.5 and square it on the left side, and then square the 4,000 squared on the right side, subtract the 4,000 squared from both sides, and then take the square root of both sides, then x is going to be 228 miles. Problem 3, we're finding a radius. So look at the diagram and it wants to know the value of x, where x is the radius of that circle. So it's showing us that RF is a tangent to the radius. So we have a right triangle. So let's use the Pythagorean theorem. C squared equals a squared plus b squared, where c is your hypotenuse, the side opposite the right angle. So, but it's that entire side. So that entire side is going to be x plus 18 in parentheses squared. Then the two legs of that right triangle, x is one leg, x squared, and 24 is the other leg. So we'll let those be a and b. So now you need to remember back to Algebra 1 how to square a binomial. So when you square a binomial, there's a formula for that. You can, it's the square of the first term. So it's x squared plus twice the product of the two terms. So the product of these two terms is 18 times x, 18x, and you double that. So it's twice the product of those two. So it's 36x plus the square of your second term. So 18 squared is 324. So that equals x squared plus 24 squared is 576. Now the nice thing about this is if you subtract x squared from both sides, they drop out of your equation and you don't have a quadratic equation to solve. It turns into a linear equation. So to just subtract the 324 from both sides, you have 36x equals 576 minus 324 is 252. Then divide both sides by 36. And x is 7. And the next problem, you're identifying a tangent, and it asked, is segment MN tangent to circle P at point N? And you need to explain that. So we need to determine, is it a tangent or not? So we need to know, is this a right angle where MN meets the radius NP? Is that a right angle or not? So the question is this a right triangle? If you will remember, and the other thing that's a little confusing about this diagram is this 13 applies to that entire side. So the length of MP is 13. So if you remember your triples from when we studied Pythagorean triples, if you look at this leg is 12, this leg is 5, that is a Pythagorean triple. There is a 5, 12, 13 Pythagorean triple, which means that that has to be a right triangle. So we have triangle MNP is a right triangle because 5, 12, 13 is a Pythagorean triple. Now, if you didn't remember your Pythagorean triples and didn't remember that was one, you would just have to use the Pythagorean theorem and plug in 13 for C and the 12 and the 5 for A and B, and just see if C squared is equal to A squared plus B squared. And if it is, you know it's a right triangle. So here we know that MN is tangent to circle P at point N by the second theorem in this lesson. The last problem is about circles inscribed in polygons. And here we have circle S is inscribed in triangle LMN. What is the perimeter of triangle LMN? So to find the perimeter, that's the measurement around, so we need to know all of the measurements of the segments around that triangle to determine that. So let's use the last theorem in this lesson that says if two tangent segments to a circle share a common endpoint outside the circle, then those two segments have to be congruent. So point L is a common point outside that triangle that's inscribed inside. So that means that LO has to equal LR, and they're both a length of 8. And then working our way around, we have point M is also a common point outside the circle. So RM has got to equal to MT, so those are both 14. And then the last, the smallest segments over on the other side where N is the common endpoint. You have ON has got to be equal to OT, and both of those are 5. So the perimeter of this, we're going to add the 8 and the 8 together is 16, the 14 and the 14 is 28, and the 5 and the 5 is 10. So if we add all those together, the perimeter of the triangle is 54.